Okay. I think this is study goal number, study goal number 22. And fracking is a really big deal. It's a hot topic. It's all over the news. There's a lot of political debate about fracking, and it's been on the AP test. Um, so fracking is an abbreviation for hydraulic fracturing. We will explain what it is, but first I have to do a little bit of discussion on natural gas itself. Remember that hydrocarbons are carbon stuck with hydrogen and or oxygen. Remember that fossil fuel deposits are usually mixed together. So you have petroleum, natural gas, coal kind of conglomerated. And then the history, physics, and chemistry of each deposit will affect the average. It's more coal or more gas. Okay. Natural gas is technically four gases. You have to know them. And they are the shortest carbon chains. You can make longer carbon chains, but as they get bigger, they have too much mass to escape gravity, and longer carbon chains tend to be less active, so they're denser, so they're liquids or eventually solids. The four carbon compounds that are gas in natural gas are methane, ethane, butane, and propane. You absolutely positively have got to know methane is a single carbon, CH4, one carbon. You can see that on your screen. And I'm not sure how much the College Board would ask you, but you might as well write it down now. Ethane, butane, and propane are C2, C3, and C4. If anybody's a carbon nerd, carbon has four bonding sites, so those are either going to be filled with hydrogens or another carbon and then hydrogens. So that's why you get this pattern of the ratio of carbon to hydrogen. Remember that if you make them any bigger, they stop being gas. That's really important. What makes them gas is they're light enough to get away. And if you stick other stuff, they stop being gas. Almost all natural gas is methane by volume. So if you have a mixed deposit, it'll be like 85% methane and then 15% of the other carbon lengths, C2, C3, and C4. So methane is much cheaper because it's much more abundant than ethane, butane, or propane. Starting at C5, you can get longer. You can go C15, C70, C120, but those are usually liquids and eventually solids. There's a key concept that I need you to imagine. It's possible to bond something to natural gas. You would just replace a hydrogen with something else. This happens naturally, and you can do this in a lab. It's possible to remove one of the hydrogens, and that bonding site, you can stick a sodium or a nitrate or whatever you want to that bonding site. But when you do that, the molecule gets too heavy and stops being gas. So the bond is possible, but the phase changes. And that's why we say that natural gas is basically free of impurities. All the stuff that we worry about in diesel fuel, for example, all the things that cause smog, generally not found in natural gas. You'll notice there's an asterisk because a few weird things can happen, but they're relatively irrelevant. Natural gas is inherently clean, and you have to know that. That's really important. So hydraulic fracturing is a way to get natural gas. The US has a ton, and we wanted to get it because it's a fossil fuel that we can sell, that we can use to power cleaner energy than the other fossil fuels. Remember that natural gas is cleaner because the impurities don't stick to the gas. If you stick them, they're not gas anymore. So when you find a pocket of natural gas, it's generally just pure carbon bonds. That's a lot of energy potential. And the US has a ton. I'd like you to write a few words and then I'll show you how it works. Fracking has some key ingredients you have to know. They're underlined and you'll have to explain this. Fracking is high pressure water, a whole bunch of fascinating chemistry. And some of that chemistry is secret, some of that chemistry is complicated. What you have to know now is that you have a lot of different chemicals. It's called fracking fluid, which is a mix of water and lubricants to make rocks more slippery, solvents to make big gas bubbles smaller, and to make the chemicals penetrate into rock. A whole bunch of mystery stuff that we don't know about. So fracking fluid is a mixture of a lot of different chemicals for different purposes, and there's sand in there. So water, chemicals, and sand is what fracking fluid is. And you inject that into the ground, and you add hydraulic pressure, and I'll show you what this does in a minute. Now, maybe you've heard there's a lot of controversy, we'll get to that later, about how these chemicals can impact groundwater. There's a lot of fascinating politics, and I have relevant science for you. You're going to finish this lecture knowing politically relevant stuff that you didn't know before. And these are called, hydraulic fracturing is used to get shale gas deposits. You can imagine sedimentary rock with a bazillion little tiny pockets. Instead of being a cap rock with a huge reservoir layer that has a lot of gas, we can use hydraulic fracturing to get gas that is in many little pockets. Visualize a dish sponge, where the dish sponge is shale, rock, and there's all these little tiny pockets, teeny little pockets of gas. We'll come back to this. By the way, it's worth noting that there is some petroleum mixed with natural gas, always, and in this case, shale gas deposits tend to have what we actually consider highly sought after petroleum. So this is a new source. It takes a lot of energy, so it's an enhanced source for that very rare type of petroleum that we don't really have in the United States, the good stuff, the honey crude petroleum, the stuff that we need to make gasoline. So there is some excitement that hydraulic fracturing could help us get a little bit of the petroleum we need for our gasoline cars. Okay. In this picture, you've got land with a couple of trucks and some plumbing and stuff. Like surface layers that include groundwater. Then you've got like rocks and then more rocks and then more rocks, and way down there, like thousands of feet down there, is one of these shale gas deposits. Visualize a bazillion little pockets, okay? So you drill a hole down to the shale gas deposit. The pipe does turn, that's fancy mechanics. And at the end of that pipe, it's got a bunch of little slits. They're like cuts. That pipe keeps getting pushed. So first you hydraulically fracture this area, then you push the pipe through and you fracture this area, then you push the pipe through. Okay, so we're gonna move that pipe. It has a lot of little slots at the end. And you put your fracking fluid down into the ground there. So far, nothing's happening. You just have fluid down in some rocks. And then you use that tower to pull up a really heavy metal weight. It's called a hydraulic ram, and you probably don't have to know that. It's like a huge anvil. And when you let that go, it'll go clang, and it hits another sheet of metal that pushes the hydraulic fracturing fluid down out of the other end. And what you've done is you've used hydraulic pressure to translate the hammer activity on the surface to water pressure at the end of the pipe, and that will break the rock. Shale is kind of soft. Maybe you have experience with this. So you go click, 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 bang, click, 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 bang, and you can hear that. If you're near one of these, you hear the clickety, 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 clickety thing, and then you hear these really loud metallic impact noises, clang, where you're using a falling ram to force a plate that shoots fluid under tremendous pressure through those little slits, and it breaks up the rock. The sand is in there so that when you break up the rock, it won't collapse again. Right? Does that make sense? Because if you used hydraulic pressure to make a crack in the rock, that's under like 7,000 feet of earth. That's a lot of pressure pushing that back together. So to keep the cracks open, you force some sand into the fluid so that it'll wedge those open, and then they can't close. That way the hydraulic pressure gets to keep traveling into new rock. It's like a foot in the door, right? Like if somebody pushes a door open so that it won't swing shut, you jam a foot in there. That's how the sand works. And all of the lubricants in these chemicals help the rocks get really slippery, and all these solvents make the fluid get into the little tiny thinnest seams in the shale, and then when there's another forceful impact from above, it will push more fluid into each of these seams, and then the sand will keep them open, and the fluid works its way deeper and deeper through the shale. Fascinating science. It's actually a really thoughtful engineering solution. I am really impressed by the nerds who thought this up. We can get a ton of gas, because once the water connects those bubbles, they just want to float, right? Like gases float, so they're going to go. So out of the top of the pipe, you get like a head of foam, like you have when you open a soda bottle and you get like the rising bubbles. That's what happens. At the top of the pipe, there's like this fizzy stuff. So there's like a little trap door on the side of the pipe where you let all that out. And then you do some fancy stuff to let the natural gas settle, and you've got a bunch of used fracking fluid. Drill deeper, add more fluid, ram that fluid, bang, 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 bang. At the end of the pipe, the fluid's going crack, 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 crack. And out of all those rocks is going fizz, 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 fizz. And so you've created another layer of fizzy stuff. You put that fizzy stuff into the process, and then you add more fluid and you push the pipe and you keep going. Fracking. If you were a business person, I could tell you that this is a very low cost energy option. So in terms of how much energy you have to put in for how many dollars you get out, it's relatively straightforward. It's fancy engineering. I'm not an expert. I'm not saying it's easy money, but in the world of fossil fuels, it's pretty easy money. And then you look at this map and it's like, whoa, that's a lot of easy money. Remember I told you, in the US energy budget, this is the biggest pool of money. So the investor class is like, whoa, big, big dollar bill, y'all. P.S. You'll notice where you live, our hills have shale. That shale continues to the coastal shelf. That's the California Bight over there. And yeah, there's quite a bit here. By the way, the whole world is getting fired up. You see that huge red spot in Russia? That is basically the biggest economic resource in the history of any Soviet state, the richest guy who made the most money in the least amount of time until Jeff Bezos just beat him. So the richest guy before the dude that started Amazon, I guess the second biggest money maker in his life, made the most money in the least amount of time by selling pipes in Russia. Because, you know, a lot of plumbing. If you'll notice, this is actually like distributed all over. Canada's psyched for this. South America's psyched for this. All over Asia, there's pockets. Look, Australia. Look, Indonesia. Look, like many separate fields throughout Africa. Like, it's a huge amount of potential. But there is a problem. Keep in mind that we get other stuff out of the ground, like food, water, and the idea of making cracks in the ground where we get our water when you're playing with hydrocarbons, a lot of those fluids are flammable and the natural gas is flammable and those little fizzy bubbles work around. This makes a lot of people very nervous. There's an award-winning small budget documentary called Gasland that showed on HBO many years ago. You can still find it. It's probably been stolen on the internet. Gasland shows you stunts like this one, where people all over the world have so many hydrocarbons entering their water that they can light their tap water on fire, and that's not good for you. You should not be drinking water. The gas is actually not that big of a problem, but those other hydrocarbons have been associated with elevated cancer risk, with a bunch of weird kinds of cancer too, some really horrible kinds. But there's a very real debate. Hold on a second. I am not saying that fracking directly causes this lady's problem. It's a hot debate. It's worth attention. I care about this lady, but I'm a nerd and I like my facts. So check this out. When people have this conversation, they'll often show you a drawing like this, where the hydraulic fracturing is pretty close to the water table so the gas can easily get out. You can see it says right there, gas flows out to your groundwater supply. Funny thing is, that's because we're used to thinking of natural gas as being fairly shallow. Most of our historic natural gas supplies are pretty low in the ground, a few hundred feet. That's where we get natural gas here in Santa Barbara, for example. You can see on the right side of your screen, conventional gas reservoirs are pretty shallow, kind of right below the water table. But most of these shale gas deposits are really far down there under a lot of rock. As a matter of fact, all of my environmentalist friends show you drawings like this one, but all of the petroleum industry shows you drawings like this one. Remember the one I showed you earlier has the Marcellus Shale at 7,000 feet below the ground, but the water table in this drawing is at 0 feet. So the question is, does that stuff down there get all the way up to the groundwater here? And different deposits, this is a different sort of question. 7,000 feet of rock, that's not very permeable. Remember, if you had 7,000 feet of rock that was permeable, the natural gas would escape, right? And if it was permeable, the groundwater would sink. Basic physics, right? The water's going down, the gas is going up. So if those weren't sealed off, they would switch places. Does that make sense? And the water would sink. And so there's like a seal in there. Those rocks are pretty tight. So for us to have this debate, we got to pick our problems. The idea that fracking fluid comes through the fracking to the groundwater, like you see in the middle of this screen, that idea seems pretty shaky. I'm not trying to take sides in this. I hate fossil fuels. So if you want to know my side, I wouldn't do this because I don't think we need fossil fuels, okay? Just saying, like, I don't want to take sides, but this one, I hope you can see that. In the middle, that doesn't look too likely. More likely is that maybe we should set some standards on what sort of pipes are used so that you can avoid this problem. And certainly where almost all of these accidents are probably caused is this one. You know, fracking fluid is really gross. And that process of letting it fizz and settle so that all the bubbles will pop and let all of the natural gas out of the fracking fluid when you get it back, that process, that seems messy. And remember, there's solvents, right? So fracking fluid wants to get through cracks in the soil, right? That's what it's designed to do. So it seems much more likely that fracking fluid can escape 30 to 200 feet down than it is that fracking fluid is rising up 7,000 feet or whatever. I'm not saying I like fracking. I'm not saying I want to ban fracking. What I am saying is the groundwater contamination is probably a practical issue that you solve at the surface. It may not be tied to the fracking itself. It's probably tied to how we handle hazardous material at the surface. You know, gasoline is the #1 contaminant of groundwater because there's so much gasoline on the surface, some tanks leak, and that stuff gets down into the groundwater. That's the primary problem with groundwater is gasoline. So my hunch when we're worried about fracking is that we need to better regulate these, the pipes that go through the groundwater first, and then this, how we manage the fluid at the surface. And I think that's how we could avoid this, the flammable water stuff. One last detail, in case anybody's curious, the volume of fracking fluid is the single greatest hazardous material disposal problem we've ever had. If you take all hazardous material on land, it's mostly fracking fluid. It's really gross, and we have bazillions of gallons. In many, many states, the production of fracking fluid is the #1 user of fresh water. We put more water into fracking than we do into food in something like 13 states. Point being that there are reasonable objections to fracking that aren't about the groundwater issues. The disposal of fracking fluid is nasty and there's tons of it to get rid of. We have tons of it because it uses a lot of fresh water. You should know those. Concerns about groundwater are complicated. Definitely a lot of water, definitely a lot of hazardous material to get rid of. By the way, the fourth concern is there's a lot of secrecy about what's in fracking fluid. And that's an interesting debate about whether industry should have secrets, you know, that affect our health. Okay. That was a big lecture, but it's a lot to know about. I'll do another video later.